This is past paper 2017, paper 2, question 2. An experiment measures the fuel consumption at various speeds for a particular model of car. The data collected is below. So the car is going at 40 miles an hour, that's kilometers per hour, 40 kilometers per hour, and the fuel consumption at that point, when it's going at that speed, that's 21 kilometers per litre. Right, that's how you measure fuel consumptions, kilometers per litre. So again, it's 40, 21, 48, 16, 56, 18, 64, 16, 88, 13, 96, 11, 112 kilometers per hour. You will use fuel up here. So it seems that if you're faster you go, the less fuel you're using, right, based on this. Okay, so they find the correlation coefficient of the data in table 1, correct 3 decimal places. Now there's a formula for that in the book, but they always tell you to use a calculator to get that, because it takes too long. There's all sorts of adding numbers, etc, etc. I did it out, but there's I eventually just did it. I don't have a calculator, so I used the one online, an online one, and you know, you're just working out a lot of numbers, right? So I put in the X and Y values there, so 40 and 21, 48, 16, etc, all the way down. The calculator will probably ask you something similar. I don't have a calculator to do that, that can do that. And it came back with a correlation coefficient of minus 0.9566, okay? So you have to do that on your calculator, really, rather than multiplying out all these numbers. You'll end up just taking the sum of you know, all of these and all of these, and then the sum of the product of them, etc., and then you square them. That's all it does. So you're better off just doing it on the calculator. It also plotted it here, but ultimately they gave us a graph to do that. And that is the correlation coefficient. So the correlation coefficient worked out as 0.9566 by my reckoning. So I got minus 0.9566, and that was the correlation coefficient. So that says, like, if you had got a correlation coefficient of 0, you've got random points. It's just completely random. If you had gotten a correlation coefficient of 1, it's a perfect line. So the 1 can be going this way, so it has a negative slope, which is minus, so it's minus 1, so they're perfectly lined going this way, or they're perfectly lined going this way. So we have something as minus 0.9566, so that implies they're pretty close to 1 going this way. And as we saw, and as we see when we plot them down here, it is indeed going this way, right? So it's close to a line, but it's not quite that. So that's the correlation coefficient, and you can do it very quickly on the calculator. So then it says, plot the points from the table on the grid below and draw the line of best fit by I. So I plot all the points there, 40, etc., put them in all the way along there, and then I drew the line of best fit. That basically you're trying to get a straight line to go through as many of the points as possible. So I got it to the first one, and then that went there. It's only approximation. You're not going to get it perfect. So I got it to go there. I hit as many of the lines as I possibly could, and it's going that way, right? So that's the line of best fit, which you've done by I, right, and which is what they wanted. Then it says the slope of the line of best fit is found to be minus 0.15. So they must have done a you know, more perfect example with some software somewhere. So they found the slope of the best line, the slope of the line of best fit is found to be minus 0.15. What does this represent in the context of data, right? So what you've got is that's the speed there, that's the fuel consumption, and that's the speed. So it's pretty easy to see that as the speed increases, the fuel consumption is decreasing. So as the speed increases, the fuel consumption is decreasing here. All right, that's all. That's what that's saying. The other thing that you could as speed increases, fuel consumption decreases. The slope of the line of the best fit is minus 0.15. That means that this the angle in here, that represents the slope, right? So essentially the slope is y, is the y coordinate of the x coordinate, so you could have 0.15 over 1, so it's 0.15 divided by 1. That means as the speed increases by 1 kilometer here, the fuel consumption drops by 0.15 kilometers per liter. That's another interpretation of the data. So there, which is probably more accurate, right? So that goes 1, that dropped by 0.15 kilometers per liter. That's the fuel consumption there, and that's the speed. That's all that means. So again, it'll drop again, it'll drop again, it'll drop again, and it keeps coming down by that amount according to the line of best fit. Then they say Mary drove from Cork to Dublin at an average speed of 96 kilometers per hour. Jane drove the same journey at an average speed of 112 kilometers per hour. Each travelled 260 kilometers and paid 132.9 cents per litre for the fuel. Find both use the model of car, the same model of car, generate data and table. Find how much longer it took Mary to complete the journey. Give your answer correct to the nearest minute. Right. So Mary was travelling at a speed of 96 kilometers per hour, right? So if she's going at 96 kilometers per hour, that means the way you work this out is the following. You get 96 kilometers is equal to 1 hour. You can put it down this way, right? 96 kilometers is equal to 60 minutes, right? And then divide across by 96, you get 1 kilometer is equal to 60 divided by 96 minutes, right? Then multiply by across by 260, you get 260 kilometers is equal to 260 multiplied by 60 over 96. I multiply this and this by 260, and that gives you, they're doing, you know, they do 96 kilometers in 1 hour, 96 kilometers in 60 minutes. They do 260 kilometers in 162.5 minutes. That's how you can work that out, right? So Mary's going at 96 kilometers per hour, which is the slower of the two, and takes 162.5 minutes to do 260 kilometers. Jane is going at 112 kilometers per hour, so 112 kilometers equal to, or implies, 1 hour. 112 kilometers is equal to 60 minutes. 1 kilometer divided across by 112. 1 kilometer is equal to 60 divided by 112 minutes. And then multiply across by 260, you get 260 kilometers equal to 260 multiplied by 60 over 112. So this 260 multiplied by 60 over 112. 260 multiplied by 60 divided by 112. That is equal to 139.28571 minutes. So it's quicker, right? So you want to find out how much longer Mary took. So you'll have to take the bigger one, which is 162.5, and then subtract the smaller time, which is minus 139.28571 minutes. And that is 23.214 minutes. And to the nearest minute, it's 23 minutes. So Jane was going quicker. Mary arrived 23 minutes later. So that's how you can work it out there, in how much time it takes to travel. Right. You could also work out time is equal to distance over speed, and you put your 260 and you divide it by 96. Right, and that's per hour, and then you multiply by 60 to get minutes, and you end up getting the same thing, right? That would have given you per hour, so it would have been 260 kilometers going at 96 kilometers per hour, and then they would cancel, you get there, and then you multiply by 60 to get minutes, right? And that's it. That would have done it right that way. So you would have got 260 multiplied by 60 divided by 96. You would have got the same result. But this way is probably a little clearer in how it gets worked out. But time is equal to distance over speed is a formula which is quite useful. Okay, and it's the same there with that one. You could have done time is equal to distance over speed. So time is equal to distance over speed, which is equal to 260 kilometers divided by 112 kilometers per hour. They can you let it multiplied by 60. You get 260 by 60 over 112. It's the same type of thing. Okay. You can see that there. So we got 23 minutes there. And based on the data in table 1 and their average speeds, find how much more Jane spent on fuel during the course of the journey. Right, so Mary was going at 96 kilometers per hour. That at 96 kilometers per hour, she's using up 11 kilometers per liter in fuel. Okay, so 96 kilometers per hour implies 11 kilometers per liter. 11 kilometers is equal to 1 liter. 1 kilometer is equal to 1 divided by 11 liters, divided across by 11. 260 kilometers is equal to 260 divided by 11 liters. Multiplying this across by 260, so you get 260 kilometers is equal to 260 divided by 11. So 260 multiply by that, 260 by that, and that gives you 23.636363 liters, and it's 132.9 cents per liter. We've used going at 96 kilometers per hour. You're using 11 kilometers for every per liter. So again, 1 kilometer you've used up 1.5 liters. 260 kilometers you've used up 23.636363 liters. If each liter is 132.9 cents, then you will have used 23 by 0.636363 multiplied by 132.9 cents. That gives 3141.272727 cents. So Mary uses up that amount of money when traveling. Okay, so it's 3141.272727. Jane is going at 112 kilometers per hour. That implies that she's using 9 kilometers per liter, which is less. Okay, so if you look there at 112, she's using 9 kilometers per liter. 9 kilometers is equal to 1 liter. 1 kilometer you've used up 1 over 9. 1 divided by 9 liters. Okay, dividing across by 9. And 260 kilometers multiply across by 260, you get 260 kilometers equal to 260 multiplied by 1 over 9 liters. So you've used, after 260 kilometers, you've used 28.8888 liters, going at 112 kilometers per hour, and you're using 9 kilometers per liter, right? So every 9 kilometers you've used a liter of petrol, is what it's saying, right? So after 1 kilometer, you used 1/9 of a liter, which makes sense, right? And then 260, etc. So 28.888 liters multiplied by 132.9 cents, which is price per liter, you get 383.9.33333 cents, right? And then we need to know the difference, how much more Jane spent. On fuel, right? How much more? Because you end up using more. You use up more fuel that way, right? Right. Yeah. So you get 383.9.3333 minus what Mary used, which is 3141.272727 cents, right? So that is 3839.333 minus 3141.272727. That is equal to 698.060606 cents, 6.98 cents. So it's Jane spent 6.98 cents more fuel on fuel during the course of the journey. That was 6.98 cents there. 0.9.